Okay, properties of equality are really important. We're going to use those properties today to solve these linear equations. We're moving away from pouches, away from coins. And why? Doesn't make sense to use coins, or pouches for that matter, when we have negative numbers. No. Okay, it doesn't make sense for us. We can't draw 8 negative things because you don't even have those. So it does not make sense. So please write that down in your notes. We do not have a way to represent negative coins. We do not. And then you finish that. So, and then the next question is, does it make sense to use coins, or pouches for that matter, when we have fractions? You can't really represent half a coin, or half a pouch, or half a, right? Or let's say it's a third. How do you represent that? So, same thing here. Write down your notes. No, it does not, ... and finish that. So no, it will not make sense for us to use coins and pouches for fractions. It just doesn't work.
You can't do a half of a pound.
Exactly.
You can't do
So that brings us to the second page here. So turn your paper over. This is the learning part for today, but I wanted to make sure you guys understand that pouches and coins is great, but it doesn't work when we have fractions, and it doesn't work when we have negatives. So we tackle problems of variables, and our goal, this is what we're literally trying to do. Whether or not you knew this, but what you were trying to do is, we want variables on one side, and we want numbers on the other side of the equality. So that means I could have, if I have an equal sign, I could try to move all my numbers over here. And if my numbers are over here, my x's are on the other side. Or, and it does not make a difference, I could have my numbers on this side and my x's on that side. But I need to separate those. I need to get my x's away from my numbers. And it takes a process. So I have this example up here, and I'm going to walk it through with you. We have 2x plus 4 equals 9 plus x minus 1. I know that this x right here is 1x. There's a coefficient of 1 in front of that. I'm going to decide I want all my x's on this side of the equation, on this side of the equals. So the first thing I'm going to do is I'm going to subtract this 1x. I'm going to get rid of it. Because I have 1x here, if I subtract 1x, it will disappear, right? But if I subtract 1x from this side, what do I have to do to this side? Subtract 1x. So, and I want you to take these notes down. So 2x plus 4 minus, and I'm going to make it 1x, equals 9 plus x minus 1 minus 1x. And I'm going to put a 1 in front of that other x. So these cancel out. So now I'm going to simplify this. 2x minus 1x equals 1x. So I'm left with, on this side, 1x plus 4 equals, I bring down my 9. This 1x and this 1x cancel each other out. That gives me 0. That's great. Minus 1. Okay. The minus 1 is, it's on the end right here. So I'm going to get rid of, because I know what 9 minus 1 is.
Is it negative 1?
Okay? It's minus 1. This minus 1, this 9 minus 1 is going to give me 8. So I'm going to rewrite it one more time. 1x plus 4 equals 8. I already decided that I wanted to put my variables on the left side of the equals. So I want all my numbers to go to the other side. So how do I get rid of this 4? Subtract 4. Right? It's a positive 4. If I can get rid of it, I'm going to subtract it. So that means I subtract 4 from this side and subtract 4 from that side. So it's plus 4 minus 4 equals 8 minus 4. 4 minus 4 is 0. And 8 minus 4 is 4. So now I'm left with 1x equals 4. So what was that? So that was weird. So x equals 4. Now, what can I do with this 4? Nora, what can I do with the 4? To make sure I'm right, I put it back in. So now, I put 4 in. 2 times 4, 8. 8 plus 4, 12. So this side is 12. 9 plus 4, 13. 13 minus 1, they're equal. They're balanced. So 4 is the right answer. Now, so that is literally what I'm trying to do. I'm trying to isolate my variable by getting my x's on one side and my numbers on the other. And look, it took a lot of steps. We have 1, 2, 3, 4. 4 steps to isolate that x and figure out what x equals. And finally, it equals 4. So when we see fractions and decimals, Stevie.
Where did you get that negative 1x on the other side?
Oh, good question. I said I wanted to get rid of this x over here. I just wanted x's on this side. Okay? So there's that x. You see that x right there? That's 1x. I just put a 1 in front of it so you guys know that it's 1x. So I said I wanted to get rid of that. I'm allowed to say that. I can do that. So what did I say? I'm going to subtract 1x. Because it's the same thing, right? If I subtract 1x from this side, what do I have to do to this side? Subtract 1x. And
Where did you get 1x on the left side?
because 2x minus 1x is 1x. What's 2 minus 1? 1. And then the x just stays. Okay? I don't, because what that 2 represents, it means I have 2 x's.
Oh, okay.
And what I'm doing, I'm getting rid of one of them. Right? Because it's multiplication. So I have, that's where I got the 1x. Does that help you, Stevie? That's an excellent question. So when I see fractions or decimals, I treat them just like they're a number. So don't get freaked out about them. I literally do exact same thing. So here I have, I want you to write this as well. Take these notes. So it's 1/4 x plus 8 equals 14. Now this is a good example of where I don't have to pick which side I'm going to have my variable on, because my variable is only on one side. Up here it was on both. And so I do have to decide, which side am I going to have it on? Whatever side I have my variable on, or I try to get my variable, the other side is where I have my numbers. Here, x is on this side, so I'm not going to move that. I'm going to keep it on this side. But I do, if my x is on this side, what do I want to do to the 8?
Move it.
I want to get rid of it. Okay? So I'm going to get rid of it. So how do I get rid of 8? Subtract it, because it's a positive 8, so I subtract it. I subtract from here, I subtract from there. So this is going to be 1/4 x plus 8 minus 8 equals 14 minus 8. Now I simplify, and I get 1/4 x equals 6. Now, a lot of you already in your head, you said, oh, hey, divide by 1/4.
Yeah, sure.
Right?
Yeah.
I bet you, well, you might not have. But you know something. When you divide by a fraction, you do something called copy dot flip flop. Okay. All I'm going to do is exactly that. I'm going to flip flop 1/4. So if I flip flop it, I'm going to multiply. There's my dot. It becomes 4/1. So what's 4 times 1? 4. And what's 1 times 4?
4.
So what does that equal in the end?
1.
1. I get my coefficient of 1 in front of my x, and that is exactly what I want. But I multiplied by 4 over 1 over here, so what do I have to do over here? Multiply by 4 over 1, which is in essence just 4. So I get x equals 24, because 6 times 4 is 24, and 1 times 1 is 1, and 24 over 1 is 24. So there's my answer. What can I do? Plug it in. I take the 24, I plug it in. I check, here's my x. So it's going to look like this. I know 24 times 1 is 24. 4 times 1 is 4. So what's 24 divided by 4? 24 divided by 4 equals 6. 6 plus 8 is 14. So today, you are going to see problems that are going to have fractions where you're going to have to do the copy dot flip flop. And you got to do it on both sides. So you will see problems like this. You are going to see today problems that are going to have negatives, like this -1. Okay? You will see problems like that. The way you get rid of a negative is by adding a positive. So these are some of the challenges that you're going to see today in the work that we're going to do. Use your notes. Those are some interesting notes, Patrick. So use those notes. The notes can help you. Miss Hankey and myself will be going around. Obviously, you have great partners beside you that can help you. We are going to tackle today page 64, and it is A all. Keep going.